Okay, chemical equilibria. We have already studied equilibria reaction. Equilibria mane hochhe it will be a reversible reaction. Equilibria constant, just like we have discussed rate constant in our first chapter, we'll discuss equilibria constant here and how it works. First, before we go to equilibria constant expression, we'll study two things, very easy: homogeneous reactions and heterogeneous reactions. Homogeneous and heterogeneous reaction. First of all, let us start with homogeneous one. Homogeneous reaction, you understand, if in a reaction all the reactants and products have the same state symbol, that reaction is a homogeneous reaction. Means they are in the same state. They are in the same state. So if you look at this reversible reaction, N2O4 gas is in dynamic equilibrium with 2 moles of NO2 gas. How is an expression? See, concentration of product squared divided by concentration of reactant squared cannot, because 2 moles, eta to the power 1 cannot, because 1 mole. So what I'm saying is, if a reaction is a homogeneous reaction, then all the products and the reactants will be in a mathematical expression, and that expression is, what is that? For all the product will be concentration of all the products will be raised to their individual number of moles as power, and divided by the reactants. That's how it goes. So if I write a reaction in this way, say A is a gas plus 2B is a gas, and a reversible reaction, say C plus 3D, say, and all are gases, then what will be the equilibria constant Kc? See, a constant Kc. It's very easy. Kc, equilibria constant, will be concentration of C to its power 1. You don't need to write, I'm just showing. D to D cube divided by concentration of A to the power 1, which you don't need to write, and B to the power B squared. So multiplication. So whatever the number of reactants and products are, if the state symbols are same, that will be the Kc expression or equilibria constant expression. And if you take all the concentration of the reactant, and moreover, one thing you need to understand, these are all, we don't write it, but it means is equilibria constant, mean concentration of A, B, C, and D at equilibria position. When the reactants and products will reach dynamic equilibria, then only this is true. And if you take concentration of C at equilibria to its number of mole as its power, and in this way, if you measure all the concentration, you will always get a constant value for this, and the constant will not change unless you change many factors like temperature and other stuffs. So do you understand this?
Yes, sir.
Yes, sir.
Samir, কি অবস্থা? Hello, sir.
জি স্যার, আলহামদুলিল্লাহ।
লাস্ট ক্লাসে ছিল না তুমি? আমরা ওই যে হোমওয়ার্ক দিছিলাম, ইয়েটা চ্যাপ্টার 2 এন্ড অফ চ্যাপ্টার কোশ্চেনস, আমরা ক্লাসে হচ্ছে ইয়ে করছিলাম, এই একটা দুইটা পেপার প্র্যাকটিস করছিলাম। বাট আমি অলমোস্ট কেউ হোমওয়ার্ক সাবমিট করে নাই, বাট আমি কিন্তু কন্টিনিউ করতেছি, বিকজ আগস্টের মধ্যে আমাদের এই যে ইকুইলিব্রিয়া কনস্ট্যান্ট এই চ্যাপ্টারটা আর অ্যাসিড বেজ ইকুইলিব্রিয়া এই দুইটা চ্যাপ্টার শেষ করা উচিত। সো দ্যাটস হাউ উইল গো। সো এই জিনিসটাই আমি এখানে ডিসকাস করছি। সো দ্যাট ইজ ডান। Determination of equilibrium constant. How will determine? Work at example 1c. 2 mole of ethanoic acid and 2 mole of ethanol are mixed and allowed to reach equilibrium with ethyl ethanoate and water at 298 Kelvin. The amount of ethanoic acid at equilibrium is found to be 0.67 mole. Calculate Kc for the reaction at 298 Kelvin. So these type of questions they will give, and accordingly we need to answer. So let me first show how we'll do. See, they will give this reaction, and you know already carboxylic acid and alcohol, if reacts together, they will form an ester and water. So the equilibrium reaction is given. So work out amounts and hence the concentration of each substance later. Just focus on this. This is your reaction, and you see the reaction. All of the reactants products are in 1:1 mole ratio, and all of them are liquid. See, liquid. So it's a homogeneous mixture. Here.
Yes, sir.
Yes.
Okay, so what you need to find Kc, and after sometimes you will find Ka, the same acid base equilibrium constant, Ka, water equilibrium constant, Kw, and same thing you will get again and again. But how will if they ask you to find the Kc value, then how will find? See, after you know the stoichiometric balance coefficients of a reversible reaction which has a homogeneous mixture, means the state symbols are same, then you need to make a table. You need to make a table like this. They have made, but let me do in my way. So you need to write all these stuffs. Acha, এখান থেকে দেখাই better. আমার space পাওয়া যাবে না। এখান থেকে দেখাই. So you see, the first thing you need to find is amount of mole at start. You see, these are given. Amount of mole at start. 2 mole of ethanoic acid reacted with 2 mole of ethanol. So 2 mole ethanoic acid, 2.00 mole ethanoic acid is reacting with 2 mole of ethanol. Do you understand this? Means,
Yes, sir.
right, number of mole at time t is equal to 0. When the reaction did not start yet, there will be 100% reactants and no product. So 2 mole, 2 mole, 0 mole, 0 mole. Fine.
Yes, sir.
Yes, sir.
Now see, the amount of ethanoic acid at equilibrium is found to be 0.67 mole. তার মানে after equilibrium has been reached, the amount of equilibrium you have found at equilibrium you have found is number 2, 0.67. ঠিক আছে? Now a number 2 এর এটা বেসিক্যালি আমি নাম্বার 2 দিতে চাই না, এখানে আমি নাম্বার 3 2 একটা পয়েন্ট নিয়ে আসবো, এটা will be number 3. Number 2 point should be changed. Okay, so we had 4 entities: entity 1, entity 2, entity 3, and entity 4. I'm not writing ethanoic acid, ethanol, ester, and water. Instead, I'm writing this one is 1, this one is 2, this one is 3, this one is 4. Okay? Fine. So amount of mole at start. Okay? Amount at start. Just I'm writing again 2, 2, 0, 0. Change, and number 3 is at equilibrium. Amount at equilibrium, what they wrote here. At equilibrium is just regarding ethanoic acid, right? 0.67 mole. So you write ethanoic acid here, 0.67. Okay, so 0.67 you wrote. So can you tell me what is the change? How many moles of ethanoic acid has been reacted? In starting it was 2, now at equilibrium it is 0.67. So how many moles has been reacted?
Sir, 1.33 moles.
Very good job. So change is negative 1.33. মানে 2 থেকে 1.33 কমে গেল, ঠিক আছে? Okay? Okay, everyone?
Yes, sir.
Yes, sir.
এর জন্যই তো 0.67 পাইছো. Now, the change will always maintain the mole ratio. The change Again, I'm saying the change is always maintain the mole ratio. It is 1.33, the first one. So if the first one is 1.33 and the stoichiometric coefficients or mole ratio for all the reactants and products is 1:1:1:1, so it will be negative 1.33. It will be positive 1.33. Since number 3, ester is the product and water is the product, these are positive, and this is how it goes. So if 2 minus 1.33 at equilibria, ethanoic acid will be 0.67, your alcohol will be 0.67 as well. 0 plus 1.33 is 1.33. So 1.33 mole of ester will form and 1.33 mole of water will form. Do you understand? Do you understand?
Yes.
Yes, sir.
So at equilibrium, mole is this, right? What we know, N equal to BC. We need the concentration. See, concentration of product to the power 1, concentration into concentration of product to the power 1 divided by concentration of reactant to the power 1 times concentration of reactant 2 to the power 1. So this is our Kc expression that you need to know. Now we know the mole. We don't need to know the volume. So if at equilibrium mole is this, so at equilibria, since all of them are liquid, so number of mole is equal to volume into concentration. So concentration is nothing but N by V, right? So N is given at equilibria, V we need to find. So at equilibria, what is the concentration? Concentration is 0.67 divided by V, because we don't know the V. So V will be saying the total amount of volume present in that apparatus, or the apparatus in which we are doing this reaction is same, right? Let us take the volume as V. Total volume will be same. In V amount, V volume, 0.67 mole of ethanoic acid is present. Do you understand?
Yes, sir.
1.33 divided by V. So we are just finding concentration. 1.33 divided by V. So concentration we have found already. So after making this table, if you know the concentration, again see, number 1, equilibrium at start, then change. What is the change? That this change is very important. Change will maintain the stoichiometric ratio, and you will know everything else. So if you find the change, so they have given us only this information. We need to understand this one. So if we know the starting mole of ethanoic acid and the equilibrium mole of ethanoic acid, we can easily find the change. And if we know the change of one, we know change. We know the change for all. So if we know the change, initial mole for all and change for all, we can easily find the equilibrium mole. And if we know the equilibrium mole, so volume will be same because they are in the same container. So volume will be same. And if we divide by the volume, we are getting the concentration and equilibrium. Now, this reaction, we have already know how to write the Kc expression. So Kc is equal to product into product to the power 1 divided by concentration of reactant into concentration of reactant. So you see 1.33 by volume into 1.33 by V divided by 0.67 by V and 0.67 by V. So V and V cancelled out, V and V cancelled out. So the thing remain is 3.94. You see no unit, because mole per dm cube times mole per dm cube divided by mole per dm cube times mole per dm cube, so no unit. You understand?
Yes, sir.
Write it down.
Sir, reactant 2 molar এটা স্কয়ার হওয়ার কথা না?
Reactant 2 mole নাই তো। কোন reactant 2 mole আছে?
মানে amount at started 2 mol দিয়া।
না এটা তো তোমাকে আমি 2 mole দিছি। এই যে এইটা তো Kc expression you will take from the stoichiometric balance equation. এখানে mole ratio টা দেখো। তোমাকে 2 mole না, তোমাকে যদি এখানে আমি 100 mole দেই প্রবলেম আছে? You have started the reaction with 100 mole. So this is not the thing we are writing in the Kc expression. The Kc expression, the rules, মানে এই রিঅ্যাকশনটা যেই রুল মেইনটেইন করছে 1:1:1:1 ratio, that will be in the Kc expression. You are not writing from here. Samir.
জি স্যার, বুঝতে পারছি।
কারণ তোমাকে আমি ধরো এইটা হচ্ছে এই স্টার্টিং এ এইটা 5 মোল দিলাম, এটা 3 মোল দিলাম, মানে will the reaction maintain the same equilibrium, মানে mole amount you are giving in the reaction vessel? No, they will react according to their rules, which is 1:1:1:1 mole ratio. So you are writing the rule. So whatever mole you give, the concentration of the reactant and product at equilibria will remain always same. That is basically the expression. Yes. এটা ভালো করে নোট নাও, এই যে চারটা পয়েন্ট, mole at start, change, equilibria, at mole at equilibria, মানে amount at equilibria, and at equilibria what is the concentration. If you find the concentration, you put those values in the Kc expression, you will get your answer. So answer, and I said earlier in when we have discussed chapter 1, if you have no unit, after cancelling out all the unit, you must write no unit. If you don't write no unit, you will lose 1 mark. You need to write no unit, because the unit will vary. Kc unit will vary from reaction to reaction. ঠিক আছে, বোঝা যায়?
Yes, sir.
Yes, sir.
নেহা, নিউ চ্যাপ্টার কিন্তু তুমি কিন্তু প্রচুর ক্লাস মিস করতেছো, আর ক্লাস মিস নিউ চ্যাপ্টার এখন এই চ্যাপ্টারটাতে ব্লক।
Yes, sir.
মার্কেট এক্সাম্পল 2টা দেখো, পারো নাকি, বুঝো নাকি? You see 0.1 mole N2O4 is placed into a cathode DMQ flask. So mole is given and volume is given. Allowed to reach equilibria with NO2 at 398 Kelvin. So temperature is, we are always stating the temperature because for your information, Kc value can be only changed by temperature. Only change, it can be only changed by temperature. So that we'll discuss later on, how temperature is changing the Kc expression. But for the time being, just know this. That's why we are always stating the temperature. Acha. 0.1 mole N2O4 is placed in a 0.1 DMQ flask and allowed to reach equilibria with NO2. At equilibria, there is 0.0171 mole of N2O4 left over. Calculate Kc at this. So amount at start 0.1 and 0, and amount at equilibria, this is number 3. They didn't write change, but I want to write you the change. If you write change, you will not have any mistake. Change. Okay. So what is the change? 0.1 and 0.071. Can you please deduct? Can you please deduct?
Sir, 0.029.
Okay, 0.029, right? So negative 0.029, and this is change. And yeah, what is the change at at the product side? Positive 0.029, and what is the mole ratio? 1:2. So if the change of reactant is 0.029, change of product should be times 2. Do you understand?
Yes, sir.
And what is that?
Sir, 58.
Huh?
58. 0.058, sir.
0.058. You see 0.058. This is basically the 0 plus 0.058 is equal to 0.058. So that is your equilibria mole, and equilibria mole for 0.1 minus 0.029, which is 0.07. So that, and if you make the table, see, if you don't make the table, then the thing is very haphazard. But if you make the table, so according to the row 1, amount at start, number 2, change, number 3, amount at equilibria, then number 4, concentration at equilibria. See, so since they have already stated the volume given, which is 0.1 DMQ flask, So 0.1 dm cube. So this one reactant divided by 0. Reactants concentration, reactants mole divided by the volume 0.1, and products mole divided by volume is equal to 0.71 mole per dm cube and 0.58 mole per dm cube. If you write the Kc expression, NO2 squared divided by N2O4 is equal to 0.58 squared divided by 0.71. Now see, mole per dm cube squared divided by mole per dm cube. So mole per dm cube will remain at numerator side. So your unit is mole per dm cube. So 0.474 mole per dm cube. So that is the answer. Kc value is this, and concentration is this. Yeah, the unit is this. You understand?
Yes, sir.
So practice. If you understand, my part is done. Now your part will start. Since you have understood, you are getting 50% marks. From 100, you will get 50. Since you have 100% understanding. Now 50% is remain. So if you don't practice, then this 50% marks will be lost. And you please don't ask me, just sir, আমি marks এত কম পাইলাম কেন? You will ask yourself, যে তুমি কতটুকু প্র্যাকটিস করছো ওইটার উপর ডিপেন্ড করবে এই 50% মার্কস। So be careful. আমি কিছু বলতেছি না, হ্যাঁ, কেউ হোমওয়ার্ক তোমার সাবমিট করো নাই। So do whatever you wish. Heterogeneous reaction এ চলে যাই, number 2. Heterogeneous reaction is one in which at least one of the reactant or product is in a different phase or different state symbol. See, calcium carbonate is solid, calcium oxide is solid, but carbon dioxide is gas. So this reaction is heterogeneous. Solid, gas, heterogeneous. Liquid, aqueous, heterogeneous. So how will write Kc expression for heterogeneous reaction? If we apply the Equilibria law to the reaction, we obtain, this is a constant, but you see this calcium oxide to the power 1, carbon dioxide concentration to the power 1 divided calcium carbonate concentration to the power 1, which should be Kc. But the issue is, if you look at calcium oxide solid in a given volume, calcium oxide concentration of calcium oxide concentration is nothing but density, which is mass by volume, right or wrong, for solid?
স্যার আবার বলবেন একটু?
Concentration মানে কি? Mass divided by volume, no? Number of particles divided by volume.
জি স্যার।
Or density.
Yes, sir.
Density is equal to mass by volume, no? The concentration is equal to density for solid.
জি স্যার।
So this calcium oxide solid concentration is a constant, and this calcium carbonate concentration is a constant. So these two constants will be incorporated inside the Kc expression. Since Kc is a constant, these two are also constant, which this value will be incorporated inside the Kc, and the true Kc for this reaction will be nothing but Kc will be concentration of carbon dioxide only. Do you understand?
Yes, sir.
Yes, sir.
স্যার হালকা কনফিউজড।
হালকা কনফিউজড। আমি যেটা বলতেছি যে তোমরা যদি ম্যাথস ভালো পড়ে থাকো, যেটা দরকার এটা হচ্ছে যে এই ক্যালসিয়াম অক্সাইডটা, if it is a constant value, if the mass by volume ratio is constant for calcium oxide, so this say this one is X times carbon dioxide divided by Y. So X by Y, এই যে ভ্যালুটা, এটা তো একটা constant value, এইটা we are incorporating inside this constant C. So if we incorporate it here, then carbon dioxide concentration is nothing but the constant, which is Kc. মানে আমরা কার্বন ডাইঅক্সাইড ক্যালসিয়াম অক্সাইড এন্ড ক্যালসিয়াম কার্বনেটের যে কনস্ট্যান্ট ভ্যালু মানে since they are solid in nature, their density or concentration is a constant value. We are incorporating these two values inside this constant value. কারণ আমাদের এতগুলো কনস্ট্যান্ট রেখা দরকার নাই তো, x একটা কনস্ট্যান্ট, y একটা কনস্ট্যান্ট, c একটা কনস্ট্যান্ট, তো আমরা সবগুলো কনস্ট্যান্টকে একটা কনস্ট্যান্ট বলতেছি, and that constant is Kc for this reaction. Samir,
জি স্যার বুঝতে পারছি।
similarly দেখো এই যে এটা আরেকটা ইকুইলিব্রিয়াম রিঅ্যাকশন, এটাও সেম Kc is equal to solid iron, এটা একটা constant, so we are incorporating that in the Kc expression, and iron oxide solid, this is another constant. So what is our Kc expression? Kc is the Kc value plus the constant value for iron and iron oxide. This is basically Kc here, and this is straightforward. See, if these two we don't incorporate in the Kc expression, what remains? Hydrogen gas to the power 4 and divided by concentration of water gas to the power 4. So that is our Kc expression. Do you understand?
জি স্যার।
So when you will calculate Kc, you don't need to consider iron and iron oxide. So that is it. That is the end of the chapter. You please do these checkpoints. If you don't do, we don't have anything to say. আমি কিছু বলবো না, কারণ অ্যাকাউন্ট করার টাইম নাই আমার, যে এটা কেন করলা না, এটা কেন করলা। জাস্ট তুমি যেটা আমি বলতেছি এই চেক পয়েন্টটা শেষ করবা, শেষ করে তুমি আমাকে ইউ উইল আস্ক মি যে স্যার আমি এটা পারি নাই, দেন আই উইল ডু। আদারওয়াইজ আমার এটা টাইম নাই তোমাকে জিজ্ঞেস করার যে এটা কি করছো, হোমওয়ার্ক কি সাবমিট করছো। তুমি হোমওয়ার্ক সাবমিট করে দিবা, আমি দেখবো যে তুমি হোমওয়ার্ক সাবমিট করছো, এবং আমি বুঝবো যে তুমি সিনসিয়ারলি এটা করতেছো। So Kc is done. Kp will start, but you come back. Immediately come back.